Factor the polynomial completely and find all its zeros. State the multiplicity of each zero. Okay, with this one, it looks very quadratic in nature. So I'm going to do a u substitution of x squared. Mainly because this one right here gives it away, because this is x squared squared. So I can rewrite this as x squared squared plus 2x squared plus 1. Now, anytime I see an x squared, I can replace it with a u. So this becomes u squared plus 2u plus 1. And then we can factor this, so it becomes u plus 1 and u plus 1. Now, remember, we're not dealing with u's at all. We're dealing with x. So I know that u equals x squared, so anytime I see a u, I'm going to replace with x squared plus 1, and then x squared plus 1 again. Now, we're going to use the factor theorem to do the rest of this. The factor theorem says that if c is a 0 of my polynomial p, then x minus c will be a factor. So I need to find the zeros of these two factors right here. So in order to find the zeros, I'm just going to set one of them equal to 0. Subtract 1 to both sides, you get x squared equals negative 1. Square root both sides, and you end up getting x equals plus or minus I. So this means that I is a 0 and negative I is a 0. So this right here ends up factoring to be x minus I and x minus a negative I, which ends up becoming x minus I and x plus I. Now, this will factor out to be the same exact thing since it's the same as this, so it'll factor out to be x minus I and x plus I. And if you notice, we have two x minus i's and two x plus i's. So it'll be x minus I squared and an x plus I squared. So my polynomial factors out to be q of x equals this. This is the factored form. Now, if I wanted to say my zeros and how many times they happen, well, it's going to be the 0 of this, which is I, which we already knew. That's right here. But this will happen twice, and then negative I will happen twice as well. And if you notice, if you talk about multiplicity, there's two i's and two negative i's as my zeros, which means there are 4 zeros, and the fundamental theorem of algebra says there must be 4 zeros since this is a degree of 4.